Today, we will move on to another problem wherein our intention is to classify various shapes. So maybe we want to start with the simple shapes, right? So what we have done here, right, you can see that there is a folder called ellipses. Okay, this ellipses has actually it has been numbered in such a way that we can identify the total number of images we have. Okay, this particular folder contains images. Okay, as the name suggested, it is expecting to contain ellipses, but what we have done, we created two classes inside that. There are two classes, right? You can see it actually has 2000 images. Okay, so leave the first digit, that is it's showing that 12,000, but out of which the one is common for all. So remaining four digits is 2000. Starting from, you can see it is 1. Okay, so starting from zeros, that is 10,001 till 12,000. So totally 2000 images. Okay, out of which the first 1000 images are actually circles, and the remaining images are the ellipses. Okay, so now we will see how do we write a code using the deep learning concepts, and we will try to classify. Okay, that's what is my idea today. Okay, so let's see, right? So this is okay, I already have created one. Right, so let me give the name for this first. This is convolutional neural network. We are writing using the convolutional. Okay, so this is ellipse or circle, right, using ENN, convolutional neural network. So we are not going to build the convolutional neural network from scratch here. We will use the built-in function. So far, you have never come across the built-in functions. Today, I'm going to introduce you to the right those concepts. Okay, what are the inbuilt commands available in MATLAB's deep learning toolbox, so that you can directly build the deep neural network. You don't have to do anything which we did earlier, like okay, I have a layer, create the layer, get the input, multiply it by the weights, add the bias, get an output, pass through the activation function, again go ahead like that, repeat it for maybe 10 times, then calculate the error backwards, error back propagation, etc. Those things are not at all required. You can see that here. Okay, this is the much easier way to implement that. Okay, right. So this is we'll begin with clear, uh, close, and CLC. I even want to turn off all the warnings. Okay, let's create another section over here. Okay, so and I'll run and move to the next section. Okay, so we created guys. Now you see from where it starts the whole concept, or the whole program what I want to write begins from, right, reading those ellipses, correct? Right, so I have to move. So right now you will be in your current folder. You have to specify that you go inside the that particular folder which whose name is ellipses, right? So for that, if you remember, the change of the directory or the current directory, cd is the command. Okay, is cd space specify the name, that is ellipses, right? So as soon as I run now, you see that your control will go inside that. So you see, as soon as I press the run button, that's all. Okay, as soon as I press this run, you can see that, right? The control went inside that. That's because CD ellipse. Anyway, I'll go back. CD ellipses. Inside the ellipse, actually, if you look carefully, right? I have also saved one mat file that is called as a type, right? Actually, this type is okay. I'll show you what is there inside the type. Okay, so I'll write type is equal to. I just have to load this file, right? What is there? It's named as type itself. Okay, so type, and I don't want to show anything. I'll come out of this. How do you come out of this particular uh, folder? You can come out of the folder by simply doing cd dot dot. You come out. Okay, now let's run. So as soon as I run this, you can see that the workspace shows you, right, a particular, right, the word type I can see over there, right? That means let's open this. Right? Let's see what is there inside this. This says that it is one into one struct. It says it has one rows 2000 columns. What is that now? Now you are very clear, right? So all the first 1000 numbers are saying that they are 1111, right? Let's see what happens after 1000. You see, after 1000 it is a different class, correct? So we named one class, that is circles, as one, and other class as zero. That's all. Okay, so one class, first 1000 belongs to class one. This is your target ultimately, correct? You're okay with that, right? So I have to access this as type dot t, because the variable name is t here. Inside the type, right? Type is a structure. So how to access the members of structure? Dot notation, correct? So you have to use a dot and you have to access this. That's all. All right, let's go ahead. Anyway, so this part is fine. So now I will categorize this. So the t, or this is the variable I'm using for target. So t is equal to, it is a category now, category 0 or category 1. If you don't specify that, right, it will take every one as integer and zeros also as an integer. I don't want integer, it is a category. Okay, it's a categorical. Convert the type dot t into categorical values and put it into the variable t. That's what is the meaning now. And now you see all our images, right? So when I have so many images, the best way to save the images as a image data store. It's like one bag containing all your data set. Okay, all the data in a bag. Specifically, it is image. Okay, the data which you are storing over there is an image. Okay, so I'll give a name IMDS, indicating that it is image data store. What is the command to? So this comes actually under the image processing toolbox. So since I'm not teaching image processing toolbox to you, I have to use this command directly without looking at the details. Okay, so this is image data store. Okay, this is one image data store. You have to specify what is the uh, folder which contains your image. You can see the image data store says location. What is the location? It is that folder ellipsis. Okay, so ellipsis is the one which contains this. Okay, then also I can specify uh, what are your variables and what is the name corresponding to that. So what are the labels? So labels are present inside our categorical variable, that is t, right? So each image that is present inside the ellipses folder has a label taken from t directly. It's straightforward, right? So then I need a count, right? How many variables I have? So I'll give a name, label count. Okay, so the label count is equal to, I can count from, again, this is a built-in, this is count each label in the image data store. So you can see that IMDS is coming here. I'll simply write. So it goes inside and calculates, right? How many labels you have. All right. So let's try to run and check whether we have done any mistake or it's fine. So I'm expecting that as soon as I run this, I'm expecting the variables to come here. Yes, yes. You can see that image data store is there, right? It contains 2000 cells in within that folder, right? So many details, right? Whatever label, etc., you can find out. Okay. Files can also be opened, but it will just say that where is the location. That's all. You can see start from 10,001 and the last one is 12,000, right? So how many total number? 2000. So leftmost column is that. So this is what it creates. It simply loads the, it keeps the address ready to load. That's all. Okay. IMDS is just that. It's not reading. It actually saving the address of all the images you have into your one particular data store. Okay, then you can see the labels count also is there, right? You already have that, the label count. So how many labels you have? Two labels, right? Label 0, 1000 category. So 1000 images have 0. Another 1000 image have category 1. That's all. Okay, each category, how many, sorry, how many variables you have, it gets stored over. I hope it is fine. Correct? Now let's try to plot something which is read from this, because I want to make sure that it contains say the required types of images, right? I just want to make sure that. So what I do, I'll try to plot some of them, right? So let's create a, okay, there is a command, a new figure, all right? So give a name to that. This is again a built-in command that is coming from image processing toolbox. So we have not come across this, right? I'll give a name to the new figure called ellipses. Okay, I'll define some variable, say n is equal to 5, maybe, and let's say n equal to 6. I don't want to display. This is m into n. Okay, m rows, n columns maybe. Right. So I will define a variable called as is equal to, I want to sort. I'll just type and then I'll explain. Okay, so randi, random integers I want to create, and how many equal to the length of, right, the type dot t. Already we know type dot t, right? I'll close this. This many random integers I want to be created, one row, and the number of columns is equal to m into, so this is m into n. So just see this. There is a sorting function which sorts minimum to maximum. What you are going to sort? Random integers. Random integers generate random integers. Fine. How many integers are created? Equal to the length of your type dot t. Okay, so type dot t says, I know that the type dot t has 2000. Okay, I'm creating random numbers. Okay, that's all. Right? Random numbers are generated whose length is equal to this much. One row, it is arranged in one row, m into n columns. M into n is 5 into 6. So 30 numbers I'm generating. Are you okay? Right. So random numbers I'm generating. No specific meaning y5, y6. You can keep 2 and 3. Absolutely fine. Okay. I'll show you what happens when I change m and n, right? Immediately. So what I do, I want to plot how many images? 30 images. That's why I took 5 into 6. You can make 6 into 5. You can make 30 into 1, etc. Whatever you want, you can change. Absolutely fine. Okay. So now I created that. Now I plot. So I need 30 plots, so I use a for, right? For, say I, it always starts from 1 and goes till this m into n. Whatever is the number, it will go till there. Okay. And what I want to do, I want to have the subplot. Subplot. What I want to plot? I want to plot n rows, n columns, out of which ith image. This is what I want to plot. Okay. In this particular plot, what you want to show? I want to show the image. So you cannot plot an image by using a plot function. For plotting the image, if you remember the data reading and writing concept, there we had discussed this command. It is im show. Okay, I want to show an image. All right, which image you want to show? It is inside imds, your data store. It's not, I have to specify dot, you have to access a specific file, because imds contains what? Imds contains the files path only, correct? So tell that read the file. I'd say it's actually a plural, right? The files, it's inside that you write this is as of I, right? So ith image I want to plot. That's all. Right? So anyway, let us. I think I just want to plot this. So I end this, end the form. Let's check whether it's working or not. I want to see 30 images now. I'll just run this section. Let me just check what is my mistake. Saying that there is an error. Line number 18. Let me run from beginning. Let's check. It's a mistake. Run in advance. Run in advance. Still. Okay. Defined function. Called simple figure. Let's see. I think on simple figure. Let's see. Let's try to keep it as simple as possible. Okay. Expected input I is 1. Let's do one of this. Oh, this looks fine. Even the figure came, right? Okay, we'll try with the title. Maybe sometimes images require a title to be. Okay. Image. Yes. Sorry, I made a very fundamental mistake. So I know that this is a structure, right? So when I say type is a structure, I cannot access that using the parenthesis, right? If you remember, so this has to be files uh, should be right. That it's see, it's actually highlighting. You have made a mistake. We didn't observe that at all. That's all. Nothing. No other issue. Everything is fine. Yes, it should run out. So that's what it is saying. All the error it is saying, I think the same. Let's see. See, no problem. It runs. You can see the screen, right? The diagram. Can you see? Just this. Now it will come visible, right? So you can see that this our figure contains, it's randomly picked. You can see the numbers, right? Numbers are random. On the top, you can see it's randomly picked up. So 87, 154, 182, randomly picked, right? So you can see that some are ellipses and some are the circle, some are the ellipses. So class is also mentioned over there near to that, right? So up to 931, it's a largest number below 1000. So it belongs to class 1. Okay, after 1000, you can see 1014, 1200, up to 1790, all are belonging to class 0. Is it okay? So let us change this like earlier. So I need 6 this. So actually, originally I wrote m into n. That's what I'm expecting now. But this should not change. M plus n. Okay, 5 rows, 6 columns. Okay, right, like that. So if you want to have a good visualization, reduce this number to a smaller. That's all. Okay, 4. So, okay, I think 4 and 5 itself is good, right? We get sufficiently large number of images plotted. Okay, that's the first part. All right, let's move further. So I will in the next part, my intention is I need the size of the images for input layer. I have to create an input layer now. So for that reason, I'll create img. Okay, this I'll put it into a new cell so that whatever is so far, whatever we have done, it's correct. It's working fine. So I don't have to trace these 3 parts once if there is some error that comes into the picture at a later stage. Okay, so that img is equal to read image. As the name suggests, you are reading it, right? The imds, the data stored into 1. Okay, so that means in vertically you read this. That's what is the meaning. So you get img. So what we'll do, we'll out of these images, right? What I'm trying to do now is that I want to divide this into uh, training and testing. All right. So normally we keep it 80 to 20. So 0.8 is for that. Remaining, that is 0.2, is for the testing. Okay, so there is a inbuilt function to split directly, right? I have 2000 images. 80% of the images I can pick at random. So this is how you do that. So IMDS train, this is the training images, and the remaining will be testing images. So that is I am data store test. So I can obtain this directly by using an inbuilt function called split split each label, right? Where in the IMDS. So by what percentage? FAC string. All right, that much do. But if you do this, it's something like very standard. I can say that take the first 80 images, leave the remaining 20 images. I don't want to do that. I want to do what is called as randomize. Each time you randomize, because randomization is very much necessary, right? We know this, right? Let's see whether this part is yes. Okay. So anyway, I didn't put the semicolon. That's why it's showing this. It's showing the whole image over there on the right hand side. This is that. Okay. Run the section. This section runs very fine. So now what I do, I define the layer. Now onwards, our convolutional neural network comes into picture. Generate your structure. Okay, generate the neural network, convolutional neural network using the built-in function. Okay, how to do that? Let's look at that. So this is how we do that. To start with, the you can give any name, but the most common name given is the layers. Okay, because this represents, it's not a keyword. There is no keyword called layers inside the in among the uh, commands or the keywords of the map. So you can directly use this as a variable, no issues. Okay, so open a square bracket and keep writing what are the layers that you need. Okay, so my first layer is, I want to start with the input layer. Input layer, in case of image processing, it has to be a image input layer. Okay, image input layer. What is the size? You need to say that how many inputs you are going to give. Correct? So that is equal to the size of that image which you had read just now. So you see the IMG, right? You see IMG here, which is 32 into 32. 32 columns and 32 rows, right? Each image, whether it can be a circle or it can be an ellipse, right? The size is 32 into 32. So I have to pass, that is size is equal to size of that IMG. That's why you read the IMG over. So see, directly you created your input layer. Okay, input is done. So recall the convolutional neural network architecture. After the image input layer, we studied this in the theory part, right? So what is the next layer? It is a convolutional layer, correct? Perform convolution. So the inbuilt command to mention that I want to put a convolutional layer here is convolution. It is a two-dimensional convolution. That's why convolution two small letter. Convolution to the layer. Okay, so yeah, you can specify. I'll come to this. I'll open with a help. Let's look at the help. So I need it's a two-dimensional convolutional neural network layer. So normally we say the filter size and the number of filters, right? What is the filter size that you expect and how many filters you want to apply is that, okay? Then followed by, I can also specify various parameters like a stride, right? What is a stride? The step size for traversing the input vertically and horizontally. In the sense, if you don't mention, it will be moving one by one step, right? If you remember, do you remember the convolution process, I keep my filter over the image, move to right by one unit, correct? You can actually increase this. You don't want to move one step, make it two steps, right? Just like you mentioned two here, like you can say 2 1 here, horizontal vertical, like that. Okay, then one more very important is the fact padding. Do you need padding or not, right? So that's also you can specify. Padding value by default it was 0, but if you can specify, you can definitely do. Then the important one, what is called as, yeah, either padding or this, right? We can use, right? So padding actually has some other parameters, like you can specify whatever is the outermost value, you can repeat that by the word same, right? So same size output you can get. Okay, so padding has to be done in such a way that so total size remains same. Do you remember this concept, right? Padding can be same, you have multiple options available. Okay, right. Okay, let's come back. So the fundamental idea is that what is the specification? You have to say filter size and number of filters, right? I want to see this is 32 into 32. I cannot give, you can give 2 cross 2, but that becomes too low. So I prefer maybe 3 cross 3. Okay, maybe let's try whether this works. And I'll repeat 8 filters. Okay, and then I also say that I want to apply the padding in such a way that result is of the same size as the original image. Are you okay with this notation? Right. So convolution layer is defined. It's fine. It's working fine. Let's go further. What is my next one? Next one should be, which is the next layer? Immediately after convolution, I have to perform what is called as a patch normalization. Correct? Just recall the basic concept we discussed, right? So simply call, this is the inbuilt function. You see, work is very simple here. I don't have to write the manual code for everything. So previously we used to write everything. What is a convolution 2D layer? We used to write a code. Now it's not required. Okay, so just to understand the basics, I taught all those things. If I teach this directly, nobody understands what is this. Okay, right. So this is batch ZA, batch normalization layer. You don't have to specify, it just normalizes. I know that, right? Then inbuilt function. No, you don't have to tell what is value. It knows. Okay. What's the next layer? Just recall. If you are able to recall, next layer has to be the pooling layer. Correct? So again, max pooling layer, but it is 2D. So 2D is different, 1D is different. That's why you need to specify if you require a 2D specifically, like max pooling 2D layer. Otherwise, max pooling layer. Right. Now you need to specify. Let's go to the see the help. Once again, it's a max pooling layer, right? I know that I'm going to get the maximum value of this. So what is the stride you are expecting? You can specify, right? See, the fundamental idea is just the pool size, right? What is the pool size? You can say 2 means 2 cross 2, 3 means 3 cross 3, 5 means 5 cross 5, like that. Then I can specify the parameters. First parameter is stride. How many shifts you want to do, right? Whether you want to do the padding, etc. You have many other options. We will not use other thing. Okay. So I just wanted to show you what it's going to do so that you can relate this to our theory concept. So when I say max pooling 2D layer, I want to go with the same one which we used in the theory part. It's just a 2 cross 2. Always the standard one I mentioned over there. If you remember, I told that always the standard one which we use, the what you call, right, size is 2, and also you always use a stride, right? Because once a portion of image is covered, you don't want to copy the same, you don't want to use the same pixels for your next pooling. So you have to shift by 2, correct? If you remember. Is it okay? So that's why I'm writing 2, right? I will shift once I copy 2 cross 2. Next, I don't use any of those pixels. I'll move it to the right by 2 units, down also by 2 units. When I move next to the next row, correct? Are you okay? Right. So that's the first thing. Now you see it is a convolutional layer, so I should have at least 2 of them. Are you okay? So what we do, I'll just copy this because you know that this same structure keeps on repeating in case of what you call this. That's a input. This is a separate layer. That's why. Now onwards hidden layer. This is hidden layer number 1. Okay. I'll move to the hidden layer number 2 by copying the same thing, but I'll just make some adjustments. Right. So what I do now in my second layer, the first number convolutional, let's say, right, convolution filter should be of size 3 itself, but I want to increase. Let's, okay, I'll make it. So these are the things which you can change when you go to the next case, right? You can make it 32 and so on. So it always doubles 8, then 16, right? Let me check what else we can write. So normalization layer, value layer, and the stride also I keep things same. Okay. Next one. I want to keep, you see now, what I do, I add a third layer. This is the third hidden layer. Okay. Input layer. This is the input layer. Hidden layer number 1. Hidden layer number 2. Hidden layer number 3. But after hidden layer, I don't want to repeat this. I want to go for my output layer. Okay. So there is a difference just before the output layer. Remember this concept. You cannot keep a coding layer. I don't want a coding layer. That's my first. So as per my rule, this is 8. This is 16. So how much do you expect now? Double of that. 32. Okay. So actually, if you want, you can keep fourth layer, right? In that case, you put back this max pooling layer here in the last line. Then later on, once again, you copy this, keep it 3 comma 64 comma something like that. Then you finish off. Okay, you can do that. Okay, now you see, right, what I do. Now, what is the final output layer? If you remember, the final output layer is called as an output layer, wherein all the previous layers output connected to every neuron that is present in the output. Are you okay? Final layers neuron, every neuron, there may be 2 neurons, 3 neurons, 10 neurons, whatever. They will collect the inputs from all the previous neurons. You call it as a fully connected layer. Do you remember that concept? Right? So I'll create a fully connected layer. What is the size? So if you remember, the number of neurons in the output layer equal to the number of classes. How many you have here? 0 and 1 class, so I have to use 2. Okay. What is the activation function? There is a difference. Previously, you had activation function which is ReLU, right? Now you don't use it, right? Now you don't use ReLU. Which is the activation function for the output layer in CNN? Do you remember? It is soft max softmax function, right? So call it by default using the inbuilt function softmax layer. That's all. You see, everything we did in the theory part, we are doing it here, but using the built-in. That's all. So just to specify that this is my output layer. So I have to get my output. So you have to use this keyword, use this particular specifier here. So this is classification, indicating that I am going to get my output here. Okay, that's all. So come back, close this bracket, and put a semicolon. So that now you see whatever the red lines were there, indicating that there were some errors. They are vanished. So this is how you define your neural network. That's all. Pretty simple, pretty straightforward. I just have to know what are the commands. That's all. No, no, I have not running. Though I run in anything, nothing will come out. There is no plot, right? Okay, just a second. I'll do one thing. What I can do now is that I run this so that the layers can be seen in this workspace. That's all. Okay, I'll run this section. So you see layers, it appears. Let's try to open and check what is there. See, okay, there is another technique. This is very useful. That is called as layer graph of whatever you call cannot display. Okay, let's check this whether it runs. No, there is some other command. Let me just check. Maybe it's a capital letter. A layer graph, not found. Yeah, layer graph. Sorry, that's all. Okay, so this is capital. That's all. It will run. Directly it should come layer graph of. Which layer graph pattern. Actually, it should come. Let me check. Same name, right? Layer names in the graph must be known. Oh, okay, okay. Actually, I have to give some name here. I have not given. That's why. Okay. Anyway, we'll come back. Right. Otherwise, I will not be able to finish this one. Right. So let me go ahead. This plot I will show you later. Okay. There is a different command for plotting. Okay. Now, okay. I have to go for a training now. Right. So the training of I can specify. I can do the training directly using this command. So the training happens in this way. So that is call the output as a network. So trained network is equal to the command is train train network, and we have if you see here we created IMDS train for training data. That's my training data. So just put it there, comma. You define something here, right? Layers, right? So that you use here. Control B, right? This is a simple command that you can give so that machine gets trained. Train network. Okay, let me check some modifications. So this is I think you need to pass even the training parameters. Yes. Yeah, you see, you have to specify another option called options. So I just passed image data store, I passed the layers, but I didn't pass what is the option. So options are the ones which, anyway, options means I have to write at least 5 6 lines of code, right? That we'll do in the next part. But I'll tell you what it is. I have to specify the machine that what algorithm I want to use for training. Okay. What is the minimum batch size? Mini batch size. Have you heard? Yes, mini batch size. Right. What is the number of epochs you want to do? Right. Do you want to validate? Right. Do you want to shuffle? Right. And do you want to plot during the training? These are the options, minimum options you can specify. Okay. So earlier versions of Matlab where there were you don't have to specify that, like you can direct, it will take some default and it will train. That's why I thought, okay, maybe it will not it may not be required as of now. That's why I thought of running this. But now in this particular version of Matlab, right, it is not allowing that because the help says that there is no option of training with only two options, right? You have to specify the third variable, which is options. So yes, I'll teach you how to do that. And right, in the next class, we'll proceed from this particular point.